going to discuss how BFO is going to treat manufacturing processes. And the fundamental thesis is that processes come in instances, and these instances are defined by the fact that they occupy a specific region of space-time. And now the question is, how do we determine the boundaries spatially of a process? How do we determine the boundaries of temporally of a process? That's much easier, of course.
Yeah.
But then the third question is, how do we distinguish a process from the spatio-temporal region which the process unfolds itself in?
I one more point is that I kind of what my write-up was doing is how do we at which point we do have to say that we have a different instance of a process. So it's happening continuously, something is happening. And which point we say we are starting or finishing new instance and coming to the next instance.
And I think that the answer to that question is determined by the vocabulary that is used when you are planning processes or monitoring processes, or when you're creating a work order for some particular part of your team, for instance. Then you're going to use terms like, well, I don't know, you're the expert.
Operation. I mean,
okay.
Something that.
No, but give me a more specific term. It's always good to start with concrete examples.
So operation to drill a hole.
Okay, so
the operation. Okay, usually when you talk about ordering, there are again hierarchies. So I'm going to talk ordering on scheduling level. So I have to make drill 5 holes on a particular machine.
Good. So
it could be different diameter, different tools, but on the same physical part.
So let's just talk about drilling a hole. That seems to be a useful place to start. When you're dealing with processes and when you're dealing with objects, indeed, there are going to be different levels of granularity. So we're not going to be concerning ourselves with molecules or even smaller physical particles. We're also not going to be dealing with the global manufacturing strategy for the United States. We're talking about
we do somewhere in the middle. Which happens.
So drilling a hole is a good place to start. Now, so let's think about the spatial location of the process first of all. Now, if we have a machine which is autonomous, it doesn't need any people to operate it, then it's relatively easy to determine which parts of the machine are involved in the drilling process. And you're going to include not only the machine and its parts, you're also going to include the object in which the hole is drilled.
Object in which hole is drilled, object or we call fixture that holds that object that doesn't move while drilling, and actually drill bit tool itself.
So all of those are objects which occupy different parts of space. The spatial location of the process is certainly going to include the spatial locations of all those objects. And now remember, the spatial location of the process is not the same at each instant during the unfolding of the process.
If you consider tool moving.
Exactly.
But,
this is dealt with by BFO. So every process occupies a certain spatio-temporal region. And at every time in that spatio-temporal region, the process itself is projected onto a specific spatial region. So we have spatial region.
The spatial region can be actually changes as process progresses.
For instance, you might move the machine across the floor of the.
I mean, transportation that happens intentionally, not unintentionally. But what about, I don't know if you worked on, in mechanical design, there is something that's called bounding box. For any object, you can have a geometrically bounding box. Would it be useful to introduce this concept into space of the process?
So the BFO does not make any decisions in that regard. It's designed to be completely flexible when concerned with those kinds of boundary decisions which don't matter.
You mentioned, before we started recording, you mentioned an example of 2 machines. They heat each other or they heat and there is a increased temperature in space between them. which is the space is not part of machine as object, it is space which kind of fiat object part that is part of this process.
So my idea is that for different purposes, whether it's work orders or maintenance or risk assessment, or you're going to have, in your terms, different bounding boxes. I would just say we cut the spatial dimension along different boundaries.
I mean, example of bounding box is in some metal stamping operations. It is forbidden while machine is working for operators to be in that space, and that's where bounding.
That's another good example.
Bounding box coming in space. So basically, they have a safety features that operator has to move out before press.
Okay, so let me introduce another dimension from BFO. So on the one hand, we have spatial regions. Now, in the factory, the spatial regions will be determined by, to some degree anyway, by bounding boxes, by a kind of frame of reference which divides the surface of the factory floor into square meters, or and then you can specify
we specify where location of the machine.
But BFO doesn't only have spatial regions; it also has sites. Now, sites are those spatial entities which are determined by, for instance, the physical boundaries or the legal boundaries or the administrative boundaries that form the locations where organisms, particularly people even more particularly, are allowed to operate or live their lives. Or so the interior of your home, or the interior of this room here, or the interior of the entire factory, or the area that the operator is not allowed to enter during a specific operation. All of these are sites, and they typically have both physical boundaries created by walls or the surface of the machine, and fiat boundaries created where there is no physical boundary. So an example of a site would be the smoking zone of a restaurant, which is divided in the good old days when we had those things. It's
now
divided.
I mean, I was in Japan 3 weeks, and they have in train cars, in restaurants, they do have a smoking zone, smoking compartments, which you cannot find at the US. And it is actually sometimes
you can
there is
find
a
them
physical
in Dulles Airport. They have smoking cubicles.
And actually, but what you said, I just remember seeing one of these cases. I was walking on the street. There is a glass panel on one side and second side, and there's nothing else. On the other two sides, there is no physical boundary, but just kind of fiat boundary. Where is it?
Okay, now we still did not deal with the process itself. We've talked about the spatial boundaries, the temporal boundaries, the sites which are formed by, for instance, decisions as to who can stand where. But we haven't talked about the process. And the idea is that a process always involves some kind of material entity which is a participant in the process. Now, typically, the participants in the process will be in the same spatial location, but that's what we'll focus on, because that's
same site.
Same site, yes. But because we're dealing with manufacturing, we can assume that is the case. But in the longer term, we're going to have to deal with processes where one participant is operating a computer, maybe in a different city. On the telephone.
Remote processing, remote processing.
So, but we'll talk about simple face-to-face.
Yeah, we can ignore remote processing.
Right, so we have at least one participant, and that participant is then either moving or changing its state. And the word state is a problematic word, which we will come back to. Let's say changing its quality. Maybe that's
one or more qualities.
Yeah. Quality is a term which we know how to define in BFO. State is a term which people define in different ways, so we tend to avoid it.
Yeah.
But in any case, those are the two things that you have to have in order to have a process: either motion or change of quality. And now motion can include change of orientation. And change of quality might involve motion too. For instance, if you get smaller or larger, or if you make a hole, indeed, that
I don't know. Okay. I mean,
making a hole is changing a quality of the thing, but also creating a new site, because that's what holes are in BFO. They're sites, into which screws, for instance, fit.
Yeah.
In fact, the origin of the BFO ontology of sites was a theory of holes, a very nice topological theory of holes, which was a new addition to standard topology, as I understand it. So
my initial point was, okay, so from manufacturing perspective, at which point I do have to say one instance of the process is finished, I'm starting new instance.
Yes, so first of all, in the Industrial Ontologies Foundry core ontology, we focus overwhelmingly on what we call planned processes.
Yes.
Now, when you have in a factory, you have a planned process. This machine is going to be used to drill 16 holes in every hour through the whole day. So we have many, many processes. We have one total process, which is the total process.
So is planned process?
No. No, we're talking now about the plan. Now, so the total process will consist of a lot of sub-processes as parts, and each sub-process.
But we are planning them. Actually, you can sometimes call designing them, and then later we execute them. So before the execution process doesn't exist.
I'm talking now about planned processes. I'll explain how that relates to the distinction between designing, planning on the one hand, and execution in a minute. Let's just think about the planned process. How do we plan to use this machine tomorrow? We plan to build 16 holes every hour, and then we have the aggregate of all the operations of the machine, which will, for simplicity's sake, assume that, let's say 15 holes, because that gives us a nice 4 minute. It will be made of 4 minute long drill action processes. And they are distinguished according to the plan, they're distinguished in no way from each other. Every single one of them is exactly the same.
You're talking for
kind
15 identical.
Yes.
Okay.
It's the same kind of
operation. But they have okay, so they are different objects, but they do have same specification, right?
Yeah. They have the same specification, and leaving aside that some of them will be specified as occurring at the beginning of the hour and so on.
No, I didn't mean when process is happening, but I meant, dimensions, diameter, and
the process specification will be identical. The process.
No, I'm talking about whole feature specification.
Yeah, the feature specification will be identical.
They are different features, but they have same. All of them have same specification.
Different instances.
Instances, yeah.
At the same
different instances
type and the same process type and the same machine instance.
Yeah.
And now, unfortunately, we need to break here.